Taking care of yourself is also taking care of others. We're all in this together.
A very warm welcome to our viewers and a very good afternoon to those who have just joined us. My name is Nowazi Dlamini and this is Home Study. You are still tuned into Eswatini TV, and right now we are doing Form 5 Mathematics with Zweli Mamba. Also joining me in the studio are our sign language interpreters Tobile Fagutse and Linda Mamba. Zweli, how are you doing this afternoon?
I'm good, Gwazi. How are you?
I'm very well, thank you very much. I understand that today we're doing sketching graphs of quadratic functions.
Yes.
Alright, so what are you expecting your Form 5 learner to have learned by the end of this lesson?
Okay, at the end of this lesson, I hope my Form 5 will know how to sketch graphs of quadratic functions and also solve other problems involving that.
Alright, okay,
Yes.
Form 5s, I hope that you are ready for your lesson. And just to remind you, we are live on YouTube and on Facebook. And if you have any questions, please feel free to use our WhatsApp number. Relevant questions, please, which are actually related to this subject, if you can ask. And please do not call us. We will not answer. Mr. Mamba, you can actually start your lesson.
Okay, thank you, Gwazi. Good day, viewers at home. A special greeting to all the Igcse mathematics students. Okay, our topic for today is sketching graphs of quadratic functions. I hope learners at home, you are ready to enjoy this lesson with me today. Yes, make sure learners you have these materials with you in order to enjoy this lesson. Make sure you have an exercise book, a squared exercise book, a pen, a pencil, a ruler, a scientific calculator. Okay, why do we need to learn this concept of quadratic functions, especially sketching the graphs of quadratic functions? One of those reasons, learners, is when you see the satellite dishes everywhere or also in our homes, you will see that those satellite dishes, they are in a certain shape. They are caved. Okay, so we call that shape a parabolic shape. Let's look at this example with me here. Let's look at this satellite dish. You will see that this satellite dish is caved. When you look at its cross-section, learners, this is the cross-section. When you look at the cross-section of the satellite dish, you will see that it is a parabol. Okay, signals from the satellite strike from any other satellite. They strike the surface of this disk, and the signal is reflected to this focus. Okay, that's where the receiver is located. That's how the satellite dish works. Okay, so you see that we apply this idea of quadratic graphs even in our real life situation. You can also look at this other example, dear learner, to see that there are many other uses of quadratic functions, okay, like in projectiles and also in architecture. Okay, so I'm sure you are ready to enjoy this lesson and looking forward to it. The objective for this lesson, dear learners, is that you should be able to sketch the graphs of quadratic functions. Okay, you should also be able to find the equation of a parabola given the sketch or the points through which it passes. And also you should be able to solve problems involving sketches of quadratic graphs. The knowledge that you require for you to understand this topic very well, you should have covered, you should know how to draw graphs of quadratic functions. You should also be able to find the midpoint of a line segment, line of symmetry, factorizing quadratic expressions, solving quadratic equations. Okay, so let's start our lesson now. Ask yourself, what is a quadratic function? This question you should be able to answer it because it's not your first time to see this topic or this concept, quadratic functions. Here I'm explaining or reminding you what a quadratic function is. Okay, these are functions of this form: y is equals to ax squared plus bx plus c, where a, b, and the c are constants, and the a is not equals to 0. This a is not supposed to be equals to 0, this a. Otherwise, when this a is 0, you no longer have a quadratic function, because for a function to be quadratic, it has to have the x, the squared term. So the variable that is squared should be there for the function to be called quadratic. Otherwise, please also notice that b and the c can be 0. Still, you'll be left with a quadratic function. Okay. A characteristic graph of a quadratic function is a parabola. You know that, okay? It is either U-shaped, we say it's concave up, or N-shaped, we say it is concave down, the graph of a quadratic function. This depends on the value of a, okay? So when a remember, is the coefficient of the x squared, of the squared term. So when a is positive, the graph is concave up. And if a is negative, the graph is concave down. Okay. So this you already know, learners. In your previous mathematics, in most cases you were asked to draw the graph of quadratic functions, and you'll be given this quadratic function here to draw its graph. So what you will do is you will construct or come up with this table with the x values and the y values. Normally you'll be given these x values, or you just given a range that you have to use, and you will find these y values. Then you will come up with these y values by substituting the x value in this equation or in this function to get the y value. After that, getting this y value or filling up this table, you will then take these points and go and plot them. Those points, those coordinates, you go to plot them in the xy plane. Here I have these points, they are plotted. Then the next thing, what you do is you join these points using your free hand, okay, to come up with a curve. So I've done that, and here is the curve. Make sure you join those points using your free hand and make a nice curve, because sometimes you are asked to use this curve to estimate other values. So make sure you join those points using a smooth curve. So today's lesson, we want to sketch the graphs of quadratic functions. Okay, we don't want to draw them. No need of using the table and getting those values. What we need to do is just sketching. So this concept is very important. So for you to sketch the graphs of quadratic functions, there are certain or key points that you need. These points includes this point here, the y-intercept where the graph cuts the y-axis. It also includes these points. We call them the x-intercept, where the graph cuts the x-axis. If that graph cuts the x-axis, it can happen that that graph doesn't cut the x-axis. So to get the x-intercept, and the next thing you are supposed to find is this turning point, because all graphs of quadratic functions, they have those things. They have the turning point. Sometimes it has the x-intercept, and it also have the y-intercept, where the graph cuts the y-axis, and also the shape. You should know the shape, whether the curve is concave up or the curve is concave down. Okay, So those are the 4 things that you have to know when sketching the graphs. Okay, so let's start now. So here I'm just highlighting the things that I've already mentioned. So you have to know where the graph is facing, up or down, from the coefficient of x squared. Also where the graph meets the y-axis, and also where the graph meets the x-axis. Number 4, the coordinate of the turning points. Okay. So now I have here an example of a quadratic graph. Okay, so I want you to notice, learners at home, that the y-intercept, this is our y-intercept in this case. The y-intercept is this value c. We call it our y-intercept because at this point we already know the x coordinate is 0. So when you go to substitute there in that equation where you have x, you put a 0, these 2 terms disappears and you are left with c. So hence the y-intercept is always this constant term without x. So this is our y-intercept. So we can get it from the equation. And also the turning point. This is the turning point, learners at home. Okay, we can get to this turning point by using the fact that quadratic graphs are symmetric. They have a line of symmetry that divides the graph into 2 equal parts. So when you have these x-intercept, you know this line divides this graph into 2 equal parts. So if you know these values, let's say this is 2, this is 4. So it's easier to find this mid value, this midpoint, by just getting the mean of these 2 numbers. You can get the x coordinate. Then the y coordinate, you just substitute back there the x coordinate to get the y coordinate. Then you are done getting the turning point. And of course, the coefficient, as I've said, will tell you whether the graph is opening upwards or downwards. Let's quickly go to an example to use this idea that we have talked about. Okay, here is an example. Sketch the graph of the function y is equals to x squared minus 5x plus 4. Okay, so let's look at these 4 things in order to sketch that graph. Okay, check first. Number 1, is the graph concave up or down? Check the coefficient of x squared. What is the coefficient of x squared? Sorry, what is the coefficient of x squared? In our case, it is 1, and 1 is positive, is greater than 0. Hence the graph will be concave up, will open upwards. Okay, now we need the y-intercept. The y-intercept, we did mention that it's where the graph cuts the y-axis, is equals to this value 4, the constant term, the term without x. Okay, so the y-intercept is 4. It cuts the y-axis at 0, 4, because the x value where the graph cuts the y-axis, the x value is 0. So we have this coordinate. It will help us to sketch that graph. And the third thing now we need is the x-intercepts. Okay, the x-intercepts can be found. Let's go back and look at this graph. Okay, I want you to notice that the x-intercept, it's where the graph cuts the x-axis. At this point, we know the y-coordinate. The y-coordinate is what? Is 0 at these 2 points. Because we know the x-axis has this equation, y is equals to 0. Y is 0 everywhere in the x-axis. So we know the y-coordinate. So now we can come back here, because we are looking for the y, we are looking for the x-intercepts now. So what we do, we set y to be equals to 0. Hence you see here we have 0 is equals to this function, the quadratic function this side. Then now we look for the x values. Okay, so in short, what are we doing? We are solving this quadratic equation. You know how to solve quadratic equation. There are many ways that you can use to solve quadratic equation, including factorization, including completing the square, including the quadratic formula. But the easiest one, of course, if it does work, is by factorization. So let's use factorization in our case. So we need to factorize this function, the quadratic function. So you know how to factorize the quadratic function. In this case, the coefficient of x squared is 1. So when you are factorizing such quadratic functions, you just open double brackets like this. So when you have opened the double brackets, you put x, and you also in the other brackets, the first term there, you put an x. Then what you do is the next numbers that you have to put now. I've said you open double brackets, then you put x in the first term inside the brackets. The first term will be x's. Then the next numbers you will put here are, you look for the factors of 4 of our C, 2 factors that when you add those 2 factors, they give you the b, the coefficient of x, which in our case is -5. When you multiply those 2 factors, they'll give you a 4. Okay, you will see that those factors are -1 and -4. Okay, when you multiply -1 and -4, you get a 4. When you add -1 and -5, you get -5. So those are the 2 factors that qualify. So you just put -1 and -4. Hence you have factorized that quadratic expression. After factorizing, what you do is this next step here. Okay, for this side to the left hand side to be equals to 0, the x minus 1 should be equals to 0, or x minus 4 should be equals to 0. Then you solve now these linear equations. These now are linear equations. They are easier to solve. You just make x the subject by adding a 1, both sides. You get x equals to 1 and x equals to 4. So these are the x-intercept, where the graph cuts the x-axis. You know it's at 1 and at 4. Okay, then what is remaining now is the turning point. Okay, let me give it to Wazi before we look at this last thing that is remaining for us to sketch this quadratic graph.
Zweli, with your permission, can we please take a short infomercial break, please?
Okay.
All right, viewers, we'll be right back after this.
Wash hands now. Wash hands now. Wash hands now. Wash hands now. Hand washing is one of the best ways to keep from getting sick and staying healthy all year long.
Welcome back to our viewers. You are still tuned in to Eswatini TV, and this is Home Study. Zweli, without wasting any time, I'll let you continue with your lesson.
Okay, welcome back, learners at home. We are continuing with our sketching of that equation I showed you earlier. We had already found the 3 things: the y-intercept, the x-intercept, and also whether the graph is concave upwards or it is concave downwards. So now we are left with the fourth thing, which is the turning point. Okay, let's continue, learners. The turning point, that's the last thing that is remaining for us to sketch the graph. So the turning point, we can use this equation, this formula, sorry, to find the x-coordinate of the turning point. Use this equation where b and the a, you remember the general form, ax squared plus bx plus c. So b and the a, b coefficient of x, a coefficient of x squared. So you can just substitute in this equation x equals to negative b over 2a to get the x coordinate of the turning point. So we have done that here. Remember our equation was this one in the previous slide. This our equation, y is equals to x squared minus 5x plus 4. So when substituting there, we get this 5 over 2. That's the x coordinate of the turning point. And we need the y coordinate. To get the y coordinate, we use this equation to get the y value. So we take this x value, we substitute here like we are doing here. Then we get our y value as negative 9 over 4. So this is the coordinate of the turning point. Okay. Another way that we could have used to find the x-coordinate, of the turning point, is just using this x-intercept. This x-intercept, we say it's 1 and 4. So we just find the mean of 1 and 4. The mean of 1 and 4 is 1 plus 4 divided by 2, and this gives us 5 over 2. Okay, so you see that we get the same thing we got here, this 5 over 2. Then you repeat what I've said in order to find the y coordinate. So now we have found the 4 things that we need to find in order to sketch these graphs. So now I hope we are ready to sketch. So we go to our x and y axis, then we show the important points. We said our y-intercept is 4, our x-intercept 1 and 4, then our turning point is this point. 5 over 2 is the same as 2.5. Okay. Then now, when you have plotted those points, no need to show other values. We only show those important values. Okay. Then we join those points. We know we are expecting a parabola, a curve. Okay, in our case it is opening upwards because we have mentioned the coefficient of x squared is positive, passing through this y-intercept, x-intercept, and here is the turning point. So you are done, learners. So I want you to practice. Of course, it doesn't come easily. You just need to practice how to sketch graphs of quadratic functions for you to be a master of that. Okay, so here is another question. I want you to sketch the graph of this quadratic function here. This quadratic function, I want you to sketch it. So I'll just help you, give you a hint so that I pass this quickly. So what we need are the 4 things I've talked about. Look at this equation that we are given here. Let's look at it together, please. It's y is equals to 9 minus x squared. Okay, so we see that the graph will be concave to what? Down. Very good, because the coefficient of x squared, look at the coefficient of x squared is negative, so it will open downwards. Okay, the next thing that we need is what? Is the y-intercept. The y-intercept we mentioned is just the term without x. So we have this 9 as our y-intercept. So now we know we have an x-axis, y-axis. So we have a y-intercept which is 9. The graph is concave down. The other things that we need are the x-intercept. We said we get the x-intercept by letting y to be 0, like I've done here in the next slide. When y is equals to 0, check here, you solve this equation. Notice we have just used the balancing method. In this case, we can use it, okay? Because we have only one term having an x, so we can make that x the subject. So we get x equals to plus or minus 9, hence these are our x-intercept, okay? We call this the roots of the function, the terms that are normally used, roots. What are roots? It's when this function is the x values when this function is equal to 0. So these are the x values. So we call them roots or zeros or just x-intercept. Then the y-intercept is 9, as I already said. Then the last thing, the fourth thing, is the midpoint. How can we get the midpoint? I did mention when you have the x-intercept, you can easily get the x coordinate of the midpoint. You just add those two numbers and divide by 2. That's what we have done here. We get what? Negative 3 plus 3 is 0. Divided by 2, you get a 0. To get the y coordinate, you substitute to the equation. Where there is x, you put 0. Then you'll see y is equals to what? 9. So you have this coordinate as our turning point. The next thing is to go and sketch with these 4 things. So now we are here, we are sketching. We said the turning point is at 0, 9. So it's at this point we have the turning point. And the x-intercept, negative 3 and 3. Okay? Then we also realize that the curve is concave down because the coefficient of x squared is negative. Hence, the graph will look like that. Okay. So I want you to notice something, dear learners at home. A quadratic function can have 0, can have 1, or 2 real roots. Okay? In short, we are saying the graph cannot intersect the x-axis, like in our example here, can intersect the x-axis at one point or at 2 distinct points. It can happen, dear learners. You can, when you practice, you will see that you can have those 3 conditions. Okay. The next thing we want to look at, dear learners at home, is the next objective. We want to see how we can find the equation of the curve now given the x-intercept or given some information, like in this question here. This activity, the graph of y is equals to px squared plus qx plus r, cuts the x-axis at these 2 points. So it cuts the x-axis at -2 and at 1/2. Okay, so we're given the x-intercepts. Okay, we're asked to find the equation now, the equation of this graph. So now how can we find the equation of the graph? We see that it is a quadratic function from this general form. Okay, we are asked to find the coefficient of x squared, coefficient of x, and the r given this information. So what we need to do, learners at home, is to recall. What we have seen is that in the previous examples, we will be given the equation. For instance, the one we had given earlier, this one, minus 5x plus 4. We'll be given this equation and we'll find the x-intercept, this x-intercept. Now we are given the x-intercept, we need to find the equation. So what we can do, we can just work backwards because we know when we are given an equation, we know how to get the x-intercepts. Now we are given the x-intercept, we need to work backwards to the equation. Let's do that together. Okay, so let's compare these two. Okay, I've included this because we have already done this, so that we take it from here. So what we do is now we are starting from the x-intercept. These are the x-intercept that we are given. So we can check the next step there that we had going backwards. You see now we have a 0 this side. So how did they get the 0? They minus 1 minus 1, you get x minus 1. So we can do that even here. You see, you minus this 1 over 2 both sides, you should get this. And also this side, you plus 2, you go and plus 2, you should come here, x plus 2 is equals to 0. So now we are at this step now. So we go back again in our recall, we check what did we do next. Next, these are the factors, we call them the factors of the quadratic function. So what we do now, we combine them, like we multiply them together and we equate to 0. Notice here, the next step what I've done here, I have rearranged this equation by multiplying to clear this fraction, the 2. Multiplying by 2 throughout, I get 2x minus 2 equals to 0. Okay, don't get lost. Okay, so we are here. The next thing is to combine the 2 and equate to 0. Here we are combining them, we are equating to 0. Okay, the next thing we do, we can also refer here, when we open the brackets here, we get this quadratic function. So the next thing we have to do, we have brackets this side, we have to remove these brackets. You know how to remove double brackets, learners. So when removing the double brackets, you will get this, and this is equals to 0. Okay, then notice now when you have opened the brackets, now what we have and collecting like terms, we are here now. We have a quadratic equation this side. That's exactly what we wanted. The next thing we do is we compare the two. Okay, the coefficient of x squared is p. Okay, and here where we are now, we have a 2. So it means that p is equals to 2, like we have. Then here q is the coefficient of x. So we come check here. The coefficient of x is 3, which means q is equals to 3. Then r, this is the term that doesn't have x. This is the one here. So r is equals to negative 2. Hence we have found that those coefficients that the question was requiring us to find the values of p, q, and the r. So you can work backwards. So here is another question, learners. It's an exam question. This one, it's asking you to find the coordinates of L, Q, and M. Notice we are asked to find the coordinates, not the values. So it is a coordinate. There must be an x coordinate and a y coordinate. So how do we find these coordinates? Notice L and M are the x-intercept. Okay, K, it's where the graph cuts the y-axis. We call it the y-intercept. So you already know how to find this y-intercept. We say that term that doesn't have an x is our y-intercept. So our y-intercept is negative 12. But we want the coordinate of k, remember, not just the value. So the coordinate of k is what? It is 0, negative 12. Because we know the y-intercept, it's when x is equals to 0. Then the x-intercept, you just equate this to 0, then you solve, you get this solutions. Okay, I've already reminded you how to solve this quadratic equation. We can factorize the left hand side. We have factorized it here. Then we get this x-intercept. Remember, we want the coordinates, not just values. So remember, the x-intercept, we said here y is equals to 0. So hence, now what we are getting is the x values. Then for the y values, we just put a 0. Hence, we have this coordinate, negative 3, 0, and 0, 4. These are the coordinates. Notice L is negative 3, 0 because L is on the negative side here. And the M is this value. M is 0, 4. Sorry, M, there's a mistake here. M is supposed to be 4 because it's the x. value. Therefore, x is 4,0. That's the value of m. Learners at home, we are coming to an end of our lesson. What we have done here is to help you see how we sketch a parabola, graphs of quadratic functions, and finding equations giving enough information, and also solving problems. Please continue practicing, otherwise it has come to the end of our lesson. I'll give it back to Waz. Thank you, viewers.
Thank you very much, Zweli. We hope to see you again sometime for another mathematics lesson.
Okay, I will do so.
Thank you so much. From Fives, grab a tiny snack. I will be right back with the biology teacher, Mr. Mduduzi Geninza, right after this.
Kids, wash your hands so you can come in and have lunch.
Okay, Mom.
Tabo, apply some soap. You shouldn't just use water only.
But my hands aren't dirty, Nolwazi.
Just because your hands don't look dirty doesn't mean they're clean. We need to wash our hands regularly with soap and running water for at least 20 seconds, just like teacher taught us, so that all virus-causing germs and bacteria are washed away.
Tabo, listen to your sister, baby. It's important to always wash your hands with soap and water for at least 20 seconds. Like right now before we eat, after using the toilet, after touching